For a start to the progress of our project, as we can see, the car have been constructed and all the electronic components have been connected to the car accordingly. The coding and the app development also is done successfully. We were waiting for the EEG headset and it had arrived on the 1st of June, Monday. So when the EEG headset arrived on Monday, the 1st of June, we immediately tested it out with our toy car. But our toy car could not be able to perform the turning mechanism because the EEG headset only can able to detect attention level but not blink strength level. Therefore, we come up with another alternative way, which is by using EMG sensor only for the turning mechanism part of our toy car. Therefore, on Wednesday the 3rd of June, we ordered the EMG sensor from Lazada. Meanwhile, we were waiting for the EMG sensor to arrive. We have done with the coding for our turning mechanism of the toy car for the EMG sensor part. Then, on the 5th of June, Friday, the EMG sensor arrived and we immediately tested it with our toy car, but still could not able to perform well. This is because our Bluetooth device failed to detect the signal from the EMG sensor. We didn't give up and we are still working on the turning mechanisms of our toy car by using the EMG sensor that we ordered. This is our car progress until now. Basically, it moves forward as the focus level increases and it stops as we stop focus. We cannot able to perform the turning mechanism since the EEG headset cannot be able to detect the blink strength. So we are still working on the turning mechanism using different components.
So this is the master code. The master would be the EOG electrodes that will be placed on the head, and we'll be connecting the electrodes to the Arduino Nano. So here's the code. Here we have set an input of peak. Peak is left, like peak is the right electrode and peak 1 is the left electrode. So we have set the input of the electrode signals to the analog 0 of the Arduino signal. And the main thing is here. So we have to get the measurement first. So once we get the measurements, the electrodes will send the signals to the Arduino will process, and once Arduino receive a signal from the right electrode, which means peak equals to 1, so the car will turn right. So when the Arduino is got the signal from the left electrode, peak 1, the car will turn left. So these are the coding for the sleeve. So we'll be using the Bluetooth module that we have already programmed as sleeve and Arduino Uno, and we will build a connection for that. And the Arduino 5 will be connected to the motor pin 10, Arduino 6 with motor pin 15, and Arduino 9 to the motor pin 7, and Arduino 10 to the motor pin 2. So the motor pin 10 we label as IZQA, 15 as IZQB, 7 as DERAA, and 2 as DERB. And this is the Bluetooth coding. We are using HZ05 Bluetooth module because HZ05 can be programmed master and slave, which means one Bluetooth will send signal to the specific slave. And first we have to code for the slave. We have to connect the Arduino and Bluetooth in a certain connections to upload the code. And first we have to upload the code. To enter the setup mode of the Bluetooth module, we have to keep on pressing the Bluetooth module button, and once the blinking at an interval of 2 seconds, then we are already entered the setup mode. Then we have to upload the code. Once we have uploaded the code, we have to program the sleeve first. First we have to go to the AT mode, and the AT mode we have to get the address of the slave. So once we got the address of the slave, and then we are done with the slave. So after we are coding for the AT, so after we have programmed the slave, we have to code for the master. So in the master, it's the same way, and we have to bind the slave address to the master so that the master can send the signals to the slave.
As we are closing in on the due date and we do not have much more time, we have split up more jobs for us, and the current activity by each member is, as for our leader Vishnu is doing the hardware part where he has to attach the EMG sensor part to the toy car. He's also doing future research on the working of the EMG sensor, and he has to test the performance of the toy car with the headset and EMG sensor set. Next group member is Rishi Arun, where he's going to order additional electronic components for the EMG sensor set from online shopping, and he also working on the software pad where he has to redo the coding for the EMG part so that it could work perfectly. Next group member is Saravanan. He's doing a good job in the progress of the video and still doing the coding part for the app development since it got some problem. Next, Harhevin, where he is doing the presentation slide and the progress report, and also doing some research on the component to be replaced for the EMG sensor in case if it doesn't not work at all.